All right, 8.3, multiplication properties of exponents. The book wants to dive right into like the rule, but I want to establish why the rule exists. So let's take a look at something simple, like 2 times 2. How can I rewrite that with powers?
2 to the power of 2.
Sure, 2 to the power of 2. In the 2 times 2 part, what if I were to put an exponent of 1 and an exponent of 1? Am I allowed to do that?
Yeah.
Oh, did it change anything?
No.
Okay. So what if I then, let's change it to say 2 to the power of 2 times 2 to the power of 2. What do each of these mean? What does this one mean?
That means 4.
But why? Because it's what?
2 times 2.
So this first one, I'm going to color code it. This first one is 2 times 2, really, right?
Mm-hmm.
The next one, 2 to the power of 2, is what?
2 times 2.
Okay, so I'm going to use this multiplication still there. And then I have another 2 times 2. So really, how else could I rewrite that with powers?
2 to the first.
2 to the
third,
fourth power, right? Whoops. What are you seeing happening?
They're
Like
just adding up how many 2's there are.
What if I were to say 2 to the first, I don't really need the first there, but I'm going to write it for emphasis, times 2 to the second. What does that actually mean?
2 to the third.
Right, because really what it means is saying this first one is 2 times, there's the times, right? Times this one is really 2 times 2. So I have 2 to the power of 3, right? Not really following an actual pattern. I'm just kind of trying to help you see what's happening here. What if I were to have 2 to the fourth times 2 to the third? What do each of these mean? What's the first 2 to the fourth
2
mean?
times 2 times 2 times
Just
2.
add up the top
Okay, so
two
that's
numbers.
right. Well, but I want you to see why. Understanding why helps you to remember rules, because rules don't help you if you don't know why. Because if you forget the rule slightly wrong, you're going to do things slightly wrong and therefore get wrong answers. So then the second, Christian or whoever, help me with this one. We got that one done. How about this one?
2 times 2 times 2
And what goes between them?
times.
Why?
Because the times over there.
Right, this times is still there. So it's really just a huge product. So it really could be written as 2 to the
7th.
Yeah. So then we get into our rule that the book wants to dive right into, but I want you to understand why. So here's your key concept or your property. Multiplying powers with the same base. The base being, in this case, the 2. Is a quick, while you're writing that, quick refresher, you don't need to write this down. If I have x to the b, x is called your base, b is called your exponent. The whole thing is called your power. Okay? All right. So multiplying powers with the same base. For every non-zero number, number a, because we're talking algebra, and integers. What are integers again? Do you remember?
And integers m.
Yeah, integers m and n. But what are integers?
Don't remember.
They are positive and negative whole numbers. Okay, so for every non-zero number a and integers m and n, we could write this. A to the m times a to the n. We could write it as a to the what?
M plus n?
Yes, m plus n. I'm adding the parentheses. Your book does not have parentheses there. Just as a side note, you need to add those powers before doing anything, right? So quick examples. You can help me in answering them. If I have 3 to the 5th times 4 to the 4th. Sorry, not 4. 3 to the 4th. They have to be the same bases. What would I get?
3 to the 9.
Right, 3 to the 9th, because I'm adding the 4 and 5.
Mm.
Or if I have variables, h to the 2nd times h to the 9th, what would that be?
H to the 11th.
Right, because it was h to the 2 plus 9, which is h to the 11th. Okay? Not too bad, I hope. Okay, let's dive into doing some examples then, where more than likely you're going to be able to tell me what to do. Example 1. 1 of 4. Rewrite each expression using the base only once. So there's an A and a B on this one. We have first 11 to the 4th times 11 to the 3rd. How can I rewrite it with just one base?
Equals 11 to the 7.
Yep. Not hard, right? Hopefully. Okay, slightly more challenging. If I have 5 to the negative 2nd times 5 to the 2nd, what do I have to do with those
5
exponents?
to the 0th.
Why?
Because you add them and they cancel out.
Right, because really it was 5 to the negative 2nd plus 2 right here, which would be 5 to the 0. What is 5 to the 0?
1.
Yeah. In this one, I would not bother trying to write out what that actually equals. Like, don't run to your calculator. That's going to be a huge number. 5 to the 0, anything to the 0, go ahead and finish it off and say what it equals. 1.
1.
Okay? Easy enough?
Mm-hmm.
Perfect. Let's run into example 2.
These are so long.
Told you. All right, simplify each expression. When we say simplify in any context, it's always going to be do as much as you algebraically are allowed to do.
To make it the smallest number possible.
Yeah. Okay, so part A. You're going to start with 2n to the 5th times 3n to the negative 2nd. Let me ask you as a quick reminder, what does 2n to the 5th mean? What's going on between the 2 and the n?
There's a parentheses around the n to the 5th.
Why? What operation is happening between 2 and n?
It's a timesing each
There's a
other.
multiplication. Don't scooch down on me. There's a multiplication here. And there's a multiplication here then, right?
Mm-hmm.
So really it's 2 times n to the 5th times 3 times n to the negative 2nd. Why does that matter?
So that'd be 2 times n to the
No, it'd be
fifth,
5
third.
times.
Ah, it's all multiplication, right?
Mm-hmm.
5 times.
I've got 1 thing, 2
So it's
things, 3
6.
things, 4. Why?
Because 2 times 3 is 6.
I can change the order of multiplication, can't I?
Yeah.
Mm-hmm.
So if I rewrite it as 2 times 3, I just changed the order. I took those 2 first.
Mm-hmm.
Times n to the 5th, times n to the negative 2nd. Do I still have all the factors there?
Yeah, so that would be 6.
So I can do this, because those are numbers, I can do it.
Mm-hmm.
And I can do something with these exponents up here, right? So yes, it would be 6. And then what? N to the
3rd.
right, because 5 adding a negative 2 is really like taking away 2, right?
Mm-hmm.
Okay, so how about this one then? What if I have 5x times 2y to the 4th times 3x to the 8th? How can you rearrange this to make sure you're doing all that you need to do to simplify? Remember what's happening,
Those are
but
the wrong. There's not the
it's
base
okay.
number.
Remember, it's still all a product, right? There's still a multiplication between the 5 and the x. There's still a multiplication between the 2 and the y, and the 3 and the x. Can I still rearrange them? Let's rearrange them. How should I start?
Okay, wait. Can you say the number one more time?
5x times 2y to the 4th times 3x to the 8th. How can I rearrange them?
Well,
What would we do in the previous one?
you can get all the numbers
You need to
together.
write that.
Um,
Okay, so we're going to write all the numbers out first. So it's 5 times 2 times 3. So
Times.
hold on. So I'm going to, because there's so many here, I'm going to make sure that I've checked them all, that I took care of them all. And I'm going to stick another times in there since it's all multiplication. And I'm going to do some rearranging again because like you pointed out, Aubrey, x and x are like bases, but not the y. So I'm going to rearrange and have the x's next to each other. So I'm going to say times x that's that one, times x to the 8th, that's that one. And then times the y to the 4th. Do you see what I did?
Mhm.
Okay, so all the factors are still there. They're just rearranged. With multiplication, we're allowed to do that. That's the commutative property of multiplication.
Mhm.
Okay, so now what?
Now you do the numbers.
Okay, 5 times 2 is
10,
times 3.
30.
Perfect. 30.
Times
Then what?
x to the 9th.
Why is it x to the 9th?
Because there's another x times x.
Yeah, there's a 1 here that doesn't have to be written.
Yeah.
We're not allowed to forget about that, though.
Mm.
And then what?
Times y to the 4th.
Mm-hmm. Am I done then?
Yeah.
Is it as simple as it can be?
Yeah.
All like bases have been combined.
All numbers have been combined.
Exactly. Okay, I'm going to give you 2 quick ones to try. Okay?
Mhm.
And I'll leave these on here. Here's an A and a B. So the first one, 2y to the 3rd times 7x to the 2nd times 2y to the 4th. And then m to the 2nd times n to the negative 2nd times 7m. This one has a feature in here that we didn't really actually talk about, but I'd like to.
The negative?
Mm-hmm. Okay, get those written down. Those of you at home, pause here and work on it, and then resume to watch as I work them out. You don't, eventually, you don't have to write it all out differently, but I'd like you to do it for now to make sure you've taken care of all of the factors and made sure you've not missed anything. Okay? Where are you? Okay.
Mm.
Simplify.
Mm.
So take a look at what I did, worked out. So you good on the first one?
Yeah.
You good on the first one?
Mm-hmm.
Okay, that's what I figured. The first one's pretty easy. The second one has this pesky little negative exponent, right?
Mm-hmm.
So when we get to this final right here, 7m to the 3rd times n to the negative 2nd, we can't leave a negative exponent. We know what to do with it. We learned about that in the first section.
Yeah.
So I showed here that it's still 7 times n to the 3rd, m to the 3rd, but this portion is what's changed to 1 over n to the 2nd. Do you remember that?
Mhm.
Yeah.
Oh yeah, we have to do that still. Negative exponents are not allowed to be left. That's not considered simplified. Like you see a negative exponent in life, you're like, wait, what? When you put it in the bottom or the other side of the fraction bar, and it's no longer negative, it doesn't mess with your brain. So that's
Well, now it
my
messes with my
explanation
brain.
of why that's more simplified. So the end of the 2nd just goes to the bottom. Do you remember that from before?
Sort of.
And it's just that part because the negative 2nd is only being applied to the n.
Yeah.
So that would be the most simplified form of that question.
Mhm.
Okay? So
Mhm.
far, so good?
Yeah.
All right. Scientific notation, we'll go back to that now. Example 3. So multiplying. Numbers, in scientific notation. So last lesson we talked about what to do when you multiply a scientific notation number by another number, and it results in something that's not technically scientific notation, because it might have been, you don't have to write this, just look.
0.0.
Yeah, 12.36 times 10 to the fourth. This portion was not left to be okay, right?
Mm-hmm.
So we learned how to deal with that. We're going to make it a little bit more complex today, in that we are going to multiply two scientific notation numbers, okay? So we're going to simplify the following. Ready? 7 times 10 to the second, there's your first scientific notation number, times 4 times 10 to the fifth. There's your second one. It's really similar to what we just did. I'm going to just highlight for emphasis, I have 7 times something, times something, times something.
Mm-hmm.
Can I rearrange them?
Yeah.
Oh, let's rearrange them into a place that makes sense. What do we want to put first?
7 times 4.
Sure.
Times.
7 times 4. Oops, that was an ugly parentheses. 7 times 4, and then I can put the two 10 exponent powers, whatever, in another set of parentheses. 10 to the second times 10 to the fifth. All right, 7 times 4 is what?
7 times 4 is 28.
Okay. And then 10 to the...
7.
Okay. Is this portion, the 28, okay for scientific notation?
No.
No. Really, I need it to be 2.8. But in order to get back to 28, what would I need to multiply it by?
10.
10. And then there's still the times 10 to the seventh. So what does that end up happening with our overall power of 10?
Then it's 2.8 times 10 to the 8th.
Good. So far, so good?
Yeah.
Okay. You gonna try one, or you think you're okay?
I don't care.
What if I throw in a negative exponent?
No.
Why?
I hate
Scientific notation, you're allowed to leave them negative. I know that's a weird double standard, I guess. Scientific notation is the only time you're allowed to leave exponents as negatives. Okay?
Mm-hmm.
Okay. So here, do this as a try this. 1.5 times 10 to the negative second times 3 times 10 to the fourth. Write that down and then take a look up when you're finished. So pause at home and solve it. And then look up and see if you did what you needed to do. Good?
Mhm.
Okay. Good?
I just need to put that
Oh,
in.
do it.
Whatever.
1.5 times 3 is, use a calculator, I don't care, 4.5.
4.5.
4.5.
This would be. Yeah.
Okay, good?
Yep.
All right, let's do our last example. So this brings it into the real world. A human body contains about 3.2 times 10 to the fourth. This is a mu L. They're called microliters of blood for each pound of body weight. You don't really need to know that right now as far as like, so whatever. It's microliters per pound of body weight. Okay? Each microliter of blood contains 5 times 10 to the sixth red blood cells, RBC. That's an ugly B. Red blood cells. Each microliter is 5 times 10 to the 6th number of red blood cells. Find the approximate number of red blood cells in the body of a 125-pound person. So you guys have heard me say in the past that units are pretty important, right? So we're trying to find how many red blood cells. Before I throw any numbers in here, because I've got a lot to deal with. That one, and that one. I don't want to mix them up and get something wrong. So if your units work out, your math should work out just fine also. So if I want red blood cells is coming from the number of pounds that the person weighs times this part up here. I'm going to highlight it. Microliters per pound, right? Microliters per pound. I'll rewrite that as pound to make it look right. And then it's also the number of cells per microliter. I
I
wrote
don't
that
even know
wrong.
what you're writing.
The symbols?
Yeah. What
I'll explain in a
is that?
second.
It's like a U.
It's a Greek letter called mu. It's right there. It's kind of got
I
a
can't see
long.
what you're writing.
It's kind of got a long tail on the other side. When we do a U, we put a tail on the right side.
Mm-hmm.
A mu has a long tail. Look, if this is the line you're writing on, mu has a little tail that hangs down below the line.
Mm.
Okay? I'm going to get rid of that though. So, in words, I would say, I want to know how many red blood cells there are in somebody that weighs a certain amount. I know that there's a certain amount of microliters per pound, and I know there are a certain number of cells per microliter, right?
Mm-hmm.
If I'm thinking just about fractions, I can put pounds over 1 because that doesn't change anything, right?
Mm-hmm.
If I look across here, if I'm thinking like fractions, where if I have like a 2 over 4 times a 6 over 2, what happens to these 2's?
They cancel out.
They do. So just like numbers, units can cancel also. So pounds will cancel with pounds.
To be
What else?
1.
Yep. So that would be a 1 and a 1, and I don't care about the units
And then
anymore then.
Microliters.
And microliters cancel to be 1. What am I left with? What's the 1 unit left?
Cells.
Yeah, which is what I wanted, right? So if my units all work out fine, my answer better work out fine also. So really I can use this big, now messy thing as kind of my formula to plug in all these numbers up here that they gave me. I have this one. Where does that go in this messy stuff? I'm gonna
That
clean it
goes
up some.
over the. That goes where the first microliter is.
Yeah, right? I'm gonna try and clean this up a little bit so we can see where everything needs to go.
I'm just gonna go to the next page.
Okay, so I highlighted in green this microliters per pound. That's gonna fill in here. Microliters, each microliter contains 5 times 10 to the 6th red blood cells. Where does that go in here?
Right there.
Ah, so this is that whole cells per microliter. That will go in here, that number, right?
Mm-hmm.
Okay. And then a 125-pound person.
Goes to pounds.
Right, so that goes here. So I can kind of see where things match up, right?
Mm-hmm.
That's why I wrote this box stuff out. If the units work out, you can figure out more easily where your numbers need to go to know how your numbers need to work out. Okay, so red blood cells. Number of red blood cells comes from pounds, which was the 125. And since I already worked out the units here, I'm going to leave my units out of my calculation. I already did it. If I didn't already do it, I would want to put them in now. Or I can show you how they actually, I'll put them in now to show you. And I can put that over 1, doesn't change it, right? Times the green. The green highlighting is 3.2 times 10 to the 4th microliter per
What's your right
pound.
microliter?
I'm showing you how it works in here even. Times the purple highlighted stuff. 5 red blood cells, 5 times 10 to the 6 red blood cells per microliter. So the 5 times 10 to the 6th red blood cell goes on top over 1 microliter. So if I just look at the units for a moment, pounds and pounds cancel. Great. Microliters and microliters cancel. Great. I'm left with red blood cells, which is what I wanted. So now all I have to do is the numbers. And it's all multiplying, right?
Mm-hmm.
So I can do it in any order. I can rewrite it as 125 times 3.2 times, I'm trying to make my times dots a little bigger, or you use parentheses. When you're dealing with dots of multiplying and dots of decimals, sometimes it's easier to just do this. It's up to you. 5. And then I still have the times 10 to the 4th and times 10 to the 6th. Times 10 to the 4th, times 10 to the 6th. Did I catch everything? I got my 125 in there, I got my 3.2 in there, and I've got my 5 in there. And I've got the 10 to the 4th and 10 to the 6th. Okay. So there's where you want to grab the calculator, because I don't know about you, but I don't really feel like multiplying this part mentally.
Aubrey.
She's doing it. It should be kind of nice, actually.
2,000.
Yep. So 2,000, I'm putting the comma in there just for my brain's keeping track of place value.
Oh, I don't like to do that.
Times 10 to the?
Times 10 to the 10th.
Cool. Okay, but is that scientific notation?
No.
No. So what do we need to do with this 2,000?
Move them over.
What do you mean?
1 second. So
I have 2. I can put it as 0.0 or not. It doesn't need to be. 2 times 10 to the?
3rd.
Right.
Then times
And I still
10
have, yep, times 10 to the 10th.
So then it's 2 times to the 13th.
Cool. Yep. Good?
Mm-hmm.
And that's red blood cells, because that was the unit we had left. Questions? All right, and that's it. Thanks for joining me.
That was long.